So this is a diagram that shows you the 7 behavior of organic chemicals in the soil. Apparently, the next few slides are the explanation. So I think I will not going to touch too much about that one. However, I'm going to cover some of the things that I did not mention earlier. Absorption I already did. So, oh yeah, now one more thing. Just now I mentioned to you that majority of these organic chemicals, they are attaching themselves to the mineral phase. However, there's another phase that I overlook, which is the organic phase of the soil. Now, when I talk about organic phase, it is actually quite potent in absorbing in absorbing the organic chemicals, simply because these compounds, they are porous. See, porous means they have a lot of surface area where these organic chemicals can attach to, and it is proven that pesticide, organic contaminants such as pesticide, they attach themselves strongly to this organic phase, and which is good because why? If that does not happen, then majority of our vegetables grown in Cameron Highlands will be having too high of the concentration of pesticide. So yeah, the vegetables grown in Cameron Highlands is safe enough, but not its soil. Yeah? Its soil has very high concentration of pesticide. Okay, so leaching, I think I've covered, so I will not going to cover that one. Leaching. So yeah, I mean, leaching, the risk is due to the contamination of groundwater. And that will happen because in terms of the leaching, I explained to you that it involved the solution of the organic compound. So most of the time, I mean, the compound of concern, usually they are relatively small. Or if it's not small, that is relatively soluble or relatively polar. So they have to be first dissolved, then only they can travel to the groundwater and then cause contamination. So these are the data that I will not going to cover. Oh yeah, now when I talk about chemical reaction, I realized that there's one that I did not cover, which is hydrolysis. Hydrolysis means the breakdown of a chemical compound with the involvement of one water molecule. Hydro means water, lysis means break. So this reaction may happen, and it also happens together with the action of biology or some sort of bacteria, because hydrolysis always comes in when it is assisted with a catalyst or maybe an enzyme. Now, in this case, if you look at the bioremediation part, when there's an enzyme coming from microbe, this enzyme assisting hydrolysis, like for example, if you're talking about organic contaminants, when you think of it, it's usually oily, isn't it? Because it's organic. And because of that, majority of the action, the mechanism we call it, how does the organic contaminants being bioremediated by bacteria? It's through a very specialized enzyme that is very similar to lipase. Lipase. I mean, this enzyme specifically breaks down oily contaminants or fats. And it's quite safe to say, majority of the bioremediation that that address the contamination of organic compounds, mostly due to lipase related enzyme, yeah, because they use hydrolysis with assistance from the enzyme. Yeah. Okay, so these are the examples of microbial metabolism, or in other words, bioremediation. Now, not to worry, because at the end of this course, the last chapter we talk about bioremediation, but it's more towards how it is managed. But today, it's more towards the technical, I mean, the principles. How does bioremediation happens? Yeah, and this is how. Part absorption, I think I've explained just now, so I skip. Persistent is organic soil, okay? And these are the data that you can refer. Please don't plain memorize. Let me just have a look. But I would like to draw your attention. Yeah? Now, usually you can see some correlation. Any organic contaminants that are relatively persistent. How do we know? You can see that it persists in the soil for a very long time. So in this case, chlorinated hydrocarbon, PCB, those are the ones that can really stay really, really long in the soil. But if you look at the size, okay, the size of these organic pollutants, those that are persistent in the soil, usually they are relatively big. Okay, they are large in molecule. You see, the persistence in soil can be explained in so many ways. One of which they are not biodegradable. I mean, most of these man-made compounds, they are usually not biodegradable because nature simply do not have its uh, its biomolecule or mechanism on how to reduce and counteract with this poisonous effect. That is why they are not biodegradable. Yeah. But there's one more factor. If you look at those persistent, and I mentioned that they are usually big, when they are big, they are very non-polar. Okay? When they're big enough, they're very oily, they're very non-polar, and here's the thing. The more non-polar of an organic pollutant, the stronger it will attach itself with the soil. Okay? If it's small, then at high temperature, they just volatilize. But if they are big, it's very difficult for them to be volatilized. And hence, in the environment, if it is a very big hydrocarbon, it will just absorb to the soil. Either absorb to the clay, the mineral phase, or maybe attach itself to the organic phase. But you know the story lah. Persistent, big, and they are absorbed strongly to the soil. So that's why they are not going anywhere. Yeah. So if they are absorbed in the soil, they are made. I mean, they persist for such a long time in the environment, and of course, they pose a danger. Whoever that comes in contact, or maybe if they migrate into the food chain, that is a concern because people don't want to die due to this contamination. And unfortunately, this has happened a lot of times, way, very frequent nowadays because, like I told you just now, most of these organic contaminants are actually already in the food chain, more so in the seafood. Yeah. And so, what can we do? Now, in the seafood, I don't think we can do too much because there's only one way you can grow seafood, which is in the ocean. And even if you want to grow seafood, it's also in the ocean. So if the ocean is contaminated, that's it. Nothing you can do. However, if you're talking about soil, okay, if the organic contaminants still in the soil and you want to reduce it, remember just now the seven behavior, two of which can reduce the organic contaminant. So we are talking about chemical reaction and bioremediation. These two have been adopted to better manage contaminated soil. So I think for today, I will just going to give you some very brief information because after this, there will be another chapter talking about bioremediation. So I'm going to talk about, what is stated in this slide. Application of chemical for certain purpose, such as application of pesticide. So this is more towards the management. Now, if you know using too much of pesticide is a sort of problem, then probably manage it. Now, in fact, this is one of the common cause of the contamination of pesticide in the environment because the user overuse it. Yeah, so sometimes you just need a small amount, but people not happy, so they just pour more than they should be, and then that will cause the environmental contamination. And then reducing the accidental spills is also another key. Now, just recently happened, kan? North Pole near Russia. The North Pole is said to be contaminated with oil spill. Well, negligence, I have to say, yeah, just like I told you earlier. And then curbing the illegal dumping of organic waste into the soil. Now, this happened a lot of times, like I told you just now, how to minimize the illegal dumping. But we haven't talked about how we best can treat these contaminants because talking about treatment, how do we uh, minimize the amount of organic contaminants in the soil, that I think will be covered in the next chapter, chapter 8, because there are like some technologies how you can use to reduce the contamination. But I think you know just now from the behavior, the chemical reaction, and also bioremediation. These are the two approaches usually used in the bio or chemical remediation of contaminated soil. So you can see right there, bioremediation, which I think I will skip. But before I skip the entire thing, I just want to remind you what you can see right here: ex situ treatment, in situ treatment. These two, listen to me carefully. It is not an example of treatment. No, it is not. Now, for your information, I just want to explain to you. Ex situ means you are transferring the contaminated soil elsewhere for treatment. In situ, it's the opposite of that. In situ means if the soil is right there, you are going to treat the soil at the same spot, no transferring at all. So I ask you, is this a way of remediation? It is not. But here's the thing, your seniors, for some reason, I don't know. I already told them in the class, please, these two are not examples of soil remediation. But in the exam, guess what? They all give me these answers. So of course, pangka. So if you listen, if you still listen carefully. These two are not examples of soil treatment. They are not. They are just the ways of transferring the soil. They are not. Okay. Okay. So I made my point. Don't repeat the same mistake when you're answering the test question. Okay, the third one is, okay. Now the third one is one example under chemical method. Okay. Now the organoclase method uses a, uh, a material we call organoclay. So I think the name itself is quite clear. It is a clay, but it has been modified. It has been modified with organics. I can't really tell you what that is. I think I already explained to you what is ex situ and in situ means. So I think I will skip this part. And I go straight to organoclays first of all. Now, in this organoclay, this material is injected into the soil, into a plume. So if this area is suspected to be containing a large concentration of the leachate that contains organic contaminants, so in order to solve this problem, engineers were going to drill a hole into this area and inject a large amount of organoclay into this area. Now, what happened is that these organoclay were going to sit in this area, and their purpose is to absorb. First of all, they're going to absorb. So these contaminants were going to move towards organoclay. Organoclay were going to absorb it. And then after that, nothing. They just absorb it and hold it. Now, this kind of behavior is akin of like locking away. They are locking away this organic contaminant so that it is not released to harm the human. So we have another word for that one. The act of locking these contaminants in one place, we call it stabilizing or immobilizing the contaminants. In other words, this action, we call it stabilization or immobilization. This is a very famous approach, a very common approach in how to handle or how to manage contaminated soil or contaminated land. Because why? At some point, this contamination is so extensive, they are so polluted, there is no way you can remove those pollutants. They're too much. So how do? They just locked it in. It's just like when you have a sampah and you want to stop these so-called contaminants from harming you, you just balut dia dengan plastic kan. You just wrap it up with plastic. It's almost like the same approach that you hold it in the same place so that it does not migrate and harm humans or the environment. So this is one way of how organoclays can handle it. But coming back, okay. So I told you just now, in situ treatment is not an example of soil treatment, but I have discovered one. You say in situ treatment, they have like a lot of ways you can do so. In situ means at the same spot, you put a lot of things. So the examples of soil treatment here, so, I mean chemical treatment at least, is at the third point, decontamination in situ. So in situ decontamination, there are so many ways. You can use washing. I mean, it's just like washing dish. You put water, you put detergent. So this is what we call water soil washing should be the right word. I mean, the right word is not here. So if you're having this slide, you may add 1 point. The key word, okay, the right word to describe the third point, the right one word is soil washing. Now, soil washing is a very famous method to remove, okay, to remove organic pollutants from the soil. So write down soil washing. Yeah. And of course, by using soil washing, either you use surfactant or you not. If you don't use surfactant, it's just water flushing. Water flushing. If you use surfactant, it's called soil. If you use surfactant, surfactant is like sabun. Yeah, but this surfactant is not like the sabun that you use in your house, kan? But it's very similar, lah. Yeah. Okay, so soil washing. But there's another one. I think it's also not here, but it's also in situ. Yeah, I think I need to add 1 point. Okay, so just now I told you soil washing, kan? And then there's another one, vacuum extraction and also heating. So these two, uh, they usually combine together. Okay? Because by using vacuum itself is not enough to volatilize the organic compound. Now, vacuum extraction, when it's combined with heating, usually these two techniques are used to address the contamination of relatively small organic compound, relatively small organic pollutants. Because with a slightly heating, um, the organic contaminants will volatilize, and then vacuum will extract it and remove it away. So this one has been used before, but depending on what situation. If the soil is contaminated with organic contaminants that can be volatilized, yes, they can be used. However, if you have PAH or PCB, those that are very persistent, very difficult to be volatilized, you still can use heating. But this heating is a very different heating. Because why? To remove PAH or POPs, okay, the ones that attach strongly to the soil, you can only remove it by incineration. So incineration, that it is conducted usually at very high temperature. I'm talking about 90, not 90, 900 degrees Celsius. In that temperature, whatever the POPs, whatever the difficult organic compounds that are strongly attached to the soil will be completely combusted. They are just burned off. So what happened? Converted to carbon dioxide and water, and end of story. Yeah. So I just told you three more examples, three more examples of soil treatment. Okay. So I started with soil washing then. Okay. Soil washing is a technique. And then the other one is thermal treatment with the vacuum extraction. And then the other type of thermal treatment is incineration. So these two are the examples, are the real examples of soil treatment. So please, if I ask you in test, give me examples of soil treatment. I do not want to see in situ treatment and ex situ treatment. I want to see those that I explained to you. Yeah.